Donc bonsoir et bienvenue à cette rencontre laser. Welcome to this laser meeting. It's going to be in English, but I'm going to do the introduction in French anyhow, and then we'll switch to another language. Donc ce soir, c'est une rencontre laser un peu différente. On accueille, comme d'habitude, 2 projets. Donc CInti qui est ici et qui va présenter avec Debbie Jewitt qui est sur cet ordinateur. Et suivi ensuite de Meredith Roth-Bernstein et Marit Miklep dans la deuxième après la pause. CInti est la lauréate, une des deux lauréats, puisque les autres c'est un groupe mixte, du projet Roots and Seeds pour la création d'une nouvelle œuvre. Et Marit Miklep est la lauréate de la résidence Maison Malina, également dans ce projet Roots and Seeds. Donc ce soir, cette session est dédiée au projet Roots and Seeds 21, Biodiversity Crisis and Plant Resistance. Et nous avons le plaisir d'avoir Tatiana Kuroshkina. We have Tatiana Kuroshkina, qui est la fondatrice et responsable de l'agence Coartis à Barcelone et qui est à l'initiative du projet Roots and Seeds, qui est donc un projet européen soutenu par Creative Europe. Et je vais lui passer le micro pour qu'elle nous explique un petit peu quel est ce projet, comment il est né, qui sont les partenaires et ce qu'on fait. And she's going to speak in English.
Thank you so much, Anik. Sorry, I'm well, it's great to see you, many faces that I already know. And as Anik said, we are partners in the project Roots and Seeds. This project has a duration of 2 years, and it's about to end in September. And within the frame of it, we are producing 2 artworks, one of them by Laura. She will explain a bit more. We have done 3 multidisciplinary cartographies, and we're working now in the guidelines of those cartographies so that everyone else can experience what we did. And Anik is organizing, this is the second laser event related to the project. Also, there are some workshops that were done in the libraries to read fragments of the very famous novel that we all know, but most of us didn't pay enough attention to the plants that are named in those novels, so we're reading those fragments. The idea is to get also emotionally in contact with the plants, and as well to find out what are the real, what is happening, why is this biodiversity crisis, how it affects us, what are the major key players here. We are trying to investigate and to bring awareness about it through the collaboration of artists and scientists. There are 4 partners involved in Roots and Seeds. It's OLATS, it's Coartis, then there is the University of Barcelona and the Ars Electronica Festival. In this edition of Ars Electronica in September, we will show all the final results, all the artworks, the research that we do about the collaborations between artists and scientists, what are the social impact do they have, these kind of collaborations, how effective they are, what could be done better, or what is already working very well. As well, there will be shown experimental publication that Anik is working on. Again, those guidelines about the multidisciplinary cartographies and many more things. So if you are in Ars Electronica this year, please visit us. And that's it. I'm very glad to be here with you today and to find out how also the residency go. And so I'm passing my micro.
Donc ce soir, il y a plusieurs singularités dans cette rencontre laser. La première singularité, encore une fois, c'est que c'est deux projets qui sont portés au sein d'un même projet plus large, Roots and Seeds. Mais la deuxième qui pour moi me semble vraiment importante, c'est que les deux projets sont en cours d'élaboration. Que Laura et Debbie sont en train encore de travailler sur la création de l'œuvre à la recherche donc de cette femelle pour E.woodii, et Marit avec Meredith. La résidence de Marit était une résidence de recherche et elle est arrivée il y a un peu plus d'une semaine. Donc elles sont encore où elle est encore dans cette phase de recherche. Et dans l'ambition de discuter de collaboration art-sciences, je trouve que c'est particulièrement intéressant ce soir parce que précisément on a deux projets qui sont encore en cours de construction. Donc comment se construit le projet, c'est aussi important. Donc maintenant, je vais organiser les ordinateurs pour que Laura et Debbie soient en ligne, et je ferai une introduction officielle de toutes les deux. Donc Laura CInti est une artiste qui vit en Angleterre, qui vit à Londres, et qui travaille dans le champ art-sciences-technologie, et notamment dans le champ du bio-art. Elle a développé énormément de projets dans le domaine art biotech, et elle est notamment la cofondatrice avec Howard Boland du collectif C-Lab, donc avec lequel tous les deux ont organisé un certain nombre de projets en bioart. Oui, je suis particulièrement heureuse d'avoir Laura ce soir avec nous parce qu'elle a créé avec Howard Boland une œuvre qui s'appelait The Martian Rose et qui était mettre une rose dans l'atmosphère martienne en laboratoire et ensuite exposer le résultat de cette rose, enfin de ce qui arrivait à cette rose. Et j'ai eu le plaisir de présenter ce projet en 2009 à la Maison européenne de la photographie dans le cadre du festival Art Outsider que j'avais co-organisé avec Jean-Luc Sauret. Donc pour moi c'est une œuvre absolument magnifique. Allez voir à quoi ça ressemble en ligne. Et ce travail de Laura et de Howard est vraiment une très belle pièce. Donc je suis ravie de la voir ce soir. Et elle va nous parler de The Living Dead, On the Trail of a Female. Et c'est une collaboration avec Debbie Jewitt. Donc Debbie est sur l'écran de mon ordinateur. Debbie est une scientifique. En anglais, on dit conservation scientist. En français, scientifique de préservation, j'imagine. De la conservation. Ok. Donc scientifique de la conservation. Elle travaille au Encephalartos KwaZulu-Natal Wildlife en Afrique du Sud. Donc Debbie est actuellement en Afrique du Sud, dans une région qui a subi les inondations récemment absolument terribles du côté de Durban. Et voilà, donc la crise de la biodiversité s'inscrit probablement dans le changement climatique. On peut imaginer aussi que ce qui s'est passé là-bas est aussi une des conséquences de ce changement climatique. Donc le Encephalartos KwaZulu-Natal Wildlife, c'est l'organisme de la région du KwaZulu-Natal qui gère c'est un organisme officiel qui gère les problèmes liés aux problèmes d'écologie et dans l'écosystème. Donc elle travaille sur les réponses et les solutions à apporter aux menaces qui pèsent sur les paysages et sur ces régions et sur les plantes. Et elle est aussi pilote de drone, ce qui joue un rôle particulier dans ce projet qu'elles ont toutes les deux. So now I'm going to give the floor to Laura and then Debbie.
Hello. Hi, I'm sorry about the technical issues. Thank you, Nick, for inviting us to share a current work in progress. It's called The Living Dead on the Trail of a Female. This work draws attention to extinct in the wild plants, and it also takes part in the global search for a female partner for one of the rarest plants in the world, the Encephalartos woodii. We are losing biodiversity faster than we can describe it. And this project is situated in the context of sobering scientific data that we are entering the planet's sixth mass extinction. We are losing hundreds of plants, animals, and insects combined every day, and the biggest drivers of this extinction are our human activities on the planet. The rate of species going extinct on Earth is at a pace never been seen before. Plants, in particular, are disappearing twice as many times as mammals, birds, and amphibians combined. The project is focused on cycads, one of the oldest surviving plant groups on the planet. They have been around for more than 300 million years. They've survived multiple mass extinctions, environmental changes. They've been around since the time of dinosaurs. And in spite of their incredibly long legacy on our planet, today, cycads are the world's most threatened plant groups. In fact, the most endangered living organisms in the world today are not rhinos or elephants, they are cycads. And they are worth millions of dollars annually in a thriving illegal market. South Africa is regarded as the global hotspot for cycad diversity. The poaching of cycads is the biggest threat to their survival, particularly the cutting of old trees in the wild, as there's a high demand for them in traditional medicine, and of course as ornamental plants in gardens. As recent newspaper headlines have put it, cycads are being loved to death. Cycads are considered status symbols by wealthy collectors worldwide, and as one collector put it, owning a rare cycad displays wealth and intelligence in a way owning luxury cars does not. The biggest threat to cycads comes from people obsessed with owning them. But these plants grow extremely slowly. They grow just 1 centimeter per year. So, lacking patience, many collectors prefer a fully grown plant, and thereby driving their legal market. And this is why the most valuable cycad, the Encephalartos woodii in Kirstenbosch Botanical Gardens in South Africa, is now secured inside a cave to prevent poachers from digging it up. Already, poaching activities in South Africa has resulted in the extinction of 3 cycad species in the wild, one of which is the Encephalartos woodii, or E.woodii for short. When E.woodii was first discovered 127 years ago, in 1895, in the Ngoya Forest in South Africa, a cluster of 4 trunks of male E.woodii was found, and all were eventually removed for safekeeping in botanical gardens. Since cycads, including E.woodii, makes offsets, that is, clones or suckers from the original plant, there are now many more plants in botanical gardens all around the world. But in the case of the E.woodii, they are all male. Reproduction in cycads is intriguing. Each individual plant is either male or female, and it can take many years for a cone to be produced before we know the sex of the plant. For reproduction, each plant produces cones and pollen, and pollen from the male plant goes transferred to the female plant by insects. In some very rare and super fascinating cases, these plants have changed sex, but we don't know how or why this happens. The E.woodii requires a female partner to reproduce, and unless a female is found, they may never reproduce again, at least naturally. Cloning is currently the only way E.woodii survives as a true species. And this, for me, is a dramatic illustration of just how easy it is to lose a species and our biodiversity. E.woodii are so rare that they are now extinct in the wild. This means that they only known to survive in botanical gardens and collections. And it only exists as male plants. And since this plant will never, unless the female is found, reproduce, the focus of this project is to search for the female. Although the plant is already extinct in nature, the area of the Ngoya Forest where the original and only E.woodii was found hasn't been fully surveyed. And there is hope that a plant may still be in the Ngoya Forest. Conservation scientist and drone pilot Debbie Jewitt, who will be speaking after me, was interested to collaborate on the project to expand on research using drone technology to search for threatened species as part of a broader conservation strategy. As the Ngoya Forest is a protected area, the project was approved for conservation research through a South African organization called Encephalartos Wildlife, and it directs and manages the nature conservation of more than 120 protected areas. And to fly the forest, through the forest, we also obtained permits and worked with the Bateliers. And this is another organization that provides aerial perspective of the environment. And they coordinate diverse missions throughout Africa in support of environmental issues. So in December 2021, we were able to conduct a manned aerial mission of the area using a really small aircraft, a two-seater aircraft called the Rainbow Cheetah. And this mission was taken by the pilot Steve Mukara from the Batelier, specifically for this project to assess the viability of later missions and to get our first glimpse of the Ngoya Forest from above. In February this year, we are able to continue our search for the elusive female using drones in the Ngoya Forest. Debbie carried out the 2-day mission over a 36-acre area of the Ngoya Forest. But just to give perspective, the Ngoya Forest is about 10,000 acres, so what we're surveying just an area of 0.36%. I will pass you over to Debbie, who will tell us more about the mission and also how this technology can be used to enhance our search. Okay.
Thank you, Laura. So, how can we use emerging technologies to assist in conservation, and in this particular case, assist in the search for a female mate for the lonely male cycad? Perhaps drones can assist in an aerial survey of specific areas of the forest. And the search areas we used were refined after the manned aircraft survey Laura referred to, which searched larger areas of the forest. And then we were guided by expert opinion on areas to search. So Ezemvelo KZN Wildlife is a licensed drone operator with the South African Civil Aviation Authority, and we have 4 qualified drone pilots. The most suitable drone we had for this project was a DJI Matrice 210 drone with a MicaSense Red Edge MX multispectral sensor. The multispectral camera, in addition to the standard red, green, and blue colors of a normal camera, has 2 additional bands it collects information from. This is the red edge and the near infrared bands. These bands are very useful for vegetation studies, and they are often used in the agricultural sector for precision agriculture. Every plant has its own unique spectral signature, and hopefully this can be used to more easily spot a cycad in the forest. So here's your physics lesson for today. I bet you didn't think you would be having a physics lesson. The visible light spectrum is the segment of the electromagnetic spectrum that the human eye can view. More simply, this range of wavelengths is called visible light. Typically, the human eye can detect wavelengths from 380 to 700 nanometers. The red band of the electromagnetic spectrum is largely absorbed by chlorophyll and reflectance is low. That's why we see vegetation as green. On the other hand, the near-infrared band is largely reflected by it. The red edge band refers to the region of this rapid change in the reflectance of vegetation in the near-infrared band range, and this then is very useful in vegetation studies. This is just a demonstration that if you want to pull out vegetation data from a multispectral image, then the spectral signature clearly shows that you should leverage the near-infrared band. So each time the multispectral sensor is triggered, it actually takes 5 photos, one in each band of blue, green, red edge, and near-infrared. The individual bands are typically shown in the grayscale, as you can see on the right-hand side of that image. However, they can be combined in software packages such as a GIS program, ArcGIS or ArcPro, on a computer, and then assigned a color ramp to visualize the information that they contain. The computer can assign 3 colors at a time in the red, green, and blue color combinations. And then in addition to these, you can create different indices to give you more information. So for instance, that front image shows the NDVI, that stands for the Normalized Differential Vegetation Index. And that shows you how healthy the vegetation is, or the actively photosynthesizing vegetation. So each band is good at distinguishing different features. So for example, the blue band or band number 1 is very good for deep water imaging to detect smoke plumes, detect atmospheric haze, and to distinguish between cloud, snow, and rock. The green band or band 2 is very good at detecting plant vigor and different broad vegetation classes, as well as discriminating plant material, as well as algal and cyanobacterial blooms. And it can be used to distinguish urban recreational areas. The red band or band 3 is useful to distinguish soil types and geological features, as well as distinguishing between the built and the natural environment, and obviously being red, it absorbs chlorophyll. The red edge band or band 4 is useful to identify plant health and age status, including chlorophyll content and leaf structure. It's good for crop monitoring to detect healthy versus diseased plants, as well as the nutritional status of plants. And then the near-infrared band or band 5 is very useful for separating water and vegetation, as well as determining biomass content, useful for archaeological sites, and then the NDVI index we've already spoken to. So we can choose different band combinations depending on the feature that we would like to identify. So in this example, on the left, we have a natural color composite, more closely resembling the colors as we would see them in real life. But on the right, we have applied a false color composite using the red edge band, and it shows actively photosynthesizing vegetation. So the deeper the red, the more actively photosynthesizing the vegetation is. On the left of this image, we can see a blue tree. It's circled in the yellow circle. And this is blue because it has died and the bare branches are showing through. So it's very easy to determine now the health of a forest and if there are dead trees. Some of the differences in the colors that we can see on the edge of the images are due to differential lighting conditions we had during our flight, with a partly cloudy sky casting shadows in some areas compared to brightly lit areas in other areas. And this is really not ideal for multispectral imagery, where a constant light condition is best. So in this color composite, we have used bands 5, 2, and 3, making use of the near-infrared band. And this color composition is good to discriminate bare areas. And we can see the dead tree we saw on the previous image. We can also see roads and other infrastructure on the bottom right image, as well as geology types, the middle image. And I've just zoomed in on the geology type, and we can see the bands of different mineral content coming through in the geology. But if we had additional sensors on our cameras, such as those on some satellite imagery, we could better discriminate geology types. This color combination is also really good to discriminate different plant materials, so we will use this going forward. Here I've zoomed into a section of the forest, and we can clearly see the unique spectral signatures of different tree species. So if we used machine learning or artificial intelligence, we could train a computer to automatically identify the tree species and then count them, which would be very useful. Although we would need additional fieldwork to first identify the trees and then to ground truth them. We can see some of the trees currently have flowers or seed pods on them, and that's in the black circle on that image. And we can also see some branches on another tree. Just below that circle, you can see the blue branches coming through. This tree is still alive. It just has a more open canopy than the dead tree we saw in the previous image. So apart from using colors, one would also search for structure. So viewed from above, the cycad would have a palm-like structure to its canopy, and this would be the sort of structure that we would look for in the images we have obtained. Here we can clearly see different structured trees and shrubs. We can see a grassland patch, different seed pods, and then in that circle we can see just a different shaped tree, and that immediately caught my eye. Unfortunately, it's not a cycad, but it's just an example of how different the structure would be from above. So have we found a female yet? Unfortunately not. However, drone technology is providing a very useful information that can be used to enhance and streamline the search. So the search continues. And with that, I'll hand back to Laura. Thank you.
Thank you, Debbie. I'm going to turn you toward the audience. Yeah, more or less. You want to add something? So thank you. You can thank both of them. And now the floor is, she has the microphone, so the floor is open for your questions or comment or information requirement.
The final artwork, will it be a video? What shape?
Well,
of the work should we expect?
sorry.
And you have to,
For the final presentation.
Okay, well,
yeah.
hi. Well, we are looking at several options. Have previous meetings with Debbie. I was considering looking at machine learning and AI, bringing that aspect into the work. I'm not sure how feasible it would be, but it's very interesting for me to bring that aspect in. And initially it was going to be more video-like and doing the search by eye, but I'm now more intrigued with adding an interactive element and machine learning, but there are many challenges. Earlier, Debbie and I were talking, to be continued.
Well, because you just mentioned AI and machine learning, actually I was not imagining that you would use this technology.
I know.
Yeah, and can you talk a little bit more about it, or maybe the both of you, what is the role of technology in this project and research?
Maybe Debbie, do you want to take this question? Okay.
Yes, sure. So one thing I'd like to point out is that the terrain where this cycad occurred, it's very, very hilly and very inaccessible. So it's not easy to search the whole of the forest in traditional ways. So if we are to do a comprehensive search, then we have to look at different ways of doing that. So one, we could do an aerial survey using a plane. Obviously, the plane needs to fly quite a lot higher than a drone does. So we can get a much higher resolution imagery from drones, which is what we've done. We can also make use of the additional sensors, as we did in this case with the multispectral sensors. So it's really about leveraging new technology to see how we can do things differently and more efficiently, because we just can't get into these areas. Some of the areas are not safe to go into. So if we can just think differently and use technology differently, I mean, we could create an aerial mosaic flying the whole forest with a manned aircraft. But again, the resolution is not really going to be high enough. So it's just about thinking how we can do things differently to the way it's been done before, and then to streamline the efforts that we are doing.
And then I think for me, it just seems like it's a natural progression from the outcomes of the drone mission, and it's a natural progression to bring in machine learning and AI, because I think it would really enhance our search in spite of all the limitations.
If I can just jump in again, with the machine learning, one needs to train the computer algorithm. So you need a lot of data in order to train the model that you have. So unfortunately, when you only have a single specimen, the male Encephalartos woodii, there's not really a lot of data that one can use to train the model. So one then would use the machine learning and the AI to look for an anomaly. You would train the model to identify the trees, the known trees and the common trees occurring in the forest, and then to single out things that are different, that are not the common species. So you would actually turn the model upside down, because you don't have enough data to say look for a cycad, because you need at least 1,000 different training images to train an image with machine learning. And obviously we don't have 1,000, we've only got one. I mean, you could maybe take 10 different pictures of the same cycad, but it's not going to be enough. So then you would train the model on the known and common species that you have in the forest, and then you would remove that from your search area and then look at what's remaining. So you would need to invert, in a sense, and mask out the known species and then look at what you've got left. But again, it helps you because you are refining your search area. Instead of having to search the entire forest area, you then cut out what is known and you only look at what's intriguing, what's different, what's unknown. And it just helps to narrow your search. So again, just looking at how we can do things differently.
Yeah, I have two questions. One is, I guess it will be difficult for you to get images of the entire forest. So how, like what percentage of the entire forest can you get drone images of? And do you have like a strategy for where to take the images? And the second question is, what happens if you find a female?
If we found a female, I think that information would be very, very sensitive information. We would, I don't know, I don't know how we would publicly relay that information, but yeah, I'm not so sure.
This is interesting. Can you develop? Is there any ethical question here? If you find a female, that it could become something for hunting and people stealing it, or?
Yeah, they say that if you found a female,
If you find a female, why would you not reveal it to the world?
oh no, because it's highly sensitive information from, botanical gardens are not sharing information with work they're doing with the E.woodii or conservation strategies that are going on. I think it would be also with the illegal market. I think it would be it would be classified information. So I'm not sure how we could share that information. I don't know if Debbie's got something to add on that.
This is really wild. I mean, yep.
So I can speak to that. Obviously, it would be a fantastic thing if we found a female mate for this male cycad. But you can imagine with such a rare species, private collectors and poachers would be very, very interested in that female plant. So the news might be shared that yes, yay, we have found a female, but the location of that species would never be revealed. We would then partner with experts in cycad, so the botanical gardens, for instance, the South African National Biodiversity Institute, who are then experts in breeding plants, and they would then work wherever that plant may be found, and maybe it's not even in the forest, maybe it's outside of the forest. They would then work and make sure that they could breed up the specimens, and then once over many years you have a collection, then maybe those could either be rewilded and put back into the wild to form a natural population, or it could be put into the nursery trade for people to buy. Obviously, it would be a highly desirable species, but the actual location would never be shared publicly. The risk is too high. We can't take that risk. The news we would share, but not the location.
You said that you had, you mentioned that a lot of cycads are in private property. If you would share this information that you need a female, don't you think, is there no chance to get a female plant from somebody who has stolen from the garden, or from the park, or from natural environment?
What they are doing, they are hybridizing the E.woodii with a female species. I think it's the closest genetically related species, and but this takes many years for like decades, 25 years before it cones, before we know the sex of the plant. But as far as we know, apart from hybrids, as far as we know that the E.woodii is only male, and they'd have to do genetic testing to verify if there was a female, that it is, E.woodii or a hybrid. No, maybe I didn't hear. Debbie, do you have something to add?
I'm sorry, I didn't actually hear that question. Would you mind repeating it?
I'm thinking maybe I didn't hear the question properly because I think I've given the different. Okay.
I was wondering if you're looking for the plants in private property who have maybe been stolen from parks, or that if you make a research about the genetical property, if you can find a female plant which is fitting for yours.
Oh, a female plant is different from the E.woodii? Oh, finding a female plant that would be different from the E.woodii, but could actually mate with the E.woodii?
They're already doing that with the species, the closely related species. But it would take many generations, many hundreds of years for it to closely resemble an E.woodii. But it would never be genetically pure E.woodii.
Yeah, it would still be a hybrid.
Hello. I have a question.
Enlève ton masque, elle a besoin de lire sur les lèvres.
Okay. Hello, I have a question about the spectrum you show quickly in your diapositive. The maximum of the spectrum is around 1 micrometer. And I'm wondering why you don't explore this spectral domain for imaging.
Sorry, Annie, could you just repeat that question for me, please?
C'est parce qu'elle montre un spectre à un moment, un graphe qui est centré autour d'un micron, et c'est un domaine de la lumière qu'elle n'explore pas dans ces images.
Oh, it said that you showed a graph with around a spectrum around 1 millimeter, and it's 1 millimeter. Micrometer, sorry, and it seems to be that is something that you are not using in your research. So, what was the question? Why don't you use this portion of a spectrum?
So the multispectral camera that we have only takes those 5 bands that I spoke to. One could leverage satellite imagery that has a lot more bands that one could use, but then your resolution is not as good as what we can get. We flew quite high on this mission, around 80 meters from our takeoff point. But given the hilly terrain, some points were lower in the valley and some points were higher. So we had a resolution of about 8 centimeters per pixel, whereas with your best satellite imagery, you would only get, well, you can get it down to 0.5 meter, that kind of stuff. So, but it's still quite an order of magnitude, and unless you pay for the very high detailed satellite imagery, but we just don't have funds for that. So at this moment in time, the drone with the multispectral camera is the best option, but leveraging satellite imagery with some funding is definitely another alternative.
You present a lot the scientific part, but you don't speak about the artistic part. Do you have any direction yet?
So you talk a lot about the scientific part, but you didn't focus that much on the artistic part. So what is the artistic intention, and where are you? Microphone.
Firstly, I'm a research-based artist, so I produce a lot of my work based on research that I get. The artistic part of this project is still in progress. It's a work in progress. And at the moment, I'm surveying all the data from both missions. And originally, it would be a control room where you could look for the plant. But as of our last meeting, the project taken a little bit shift, and I'm still working on it. Okay. It would be movie, interactive. But I'll leave it there. Okay. Yeah.
Thank you. I understand that it's really tricky to access the forest. Hence, you have the need to use this drone. But I'm still wondering if you may go to the forest or to some accessible part of the forest to kind of have a physical, sensory encounter with the forest as well. I'm thinking about two words that we could contrast or that work. Yeah, and there is this French historian, Frédéric E.woodii, which is proposing two relations to the world. That is the point of view, so le point de vue, and she compares it or connects it or puts it in, in contrast to le point de vie, which is more the point of the living. So kind of like putting into dialogue two positions towards the world. That is this kind of overarching view of the world, and at the same time also to be with the trees, with the plants, with the forest.
No, I just wanted to add that it must be noted that when the project started, we were in COVID, and I couldn't even get access to the cycad that is sitting in Kew Gardens. I had to make special arrangements for people that work there to take photographs for me. And I could only get access once the restrictions were limited. And when I got in touch with Debbie, there were also restrictions to South Africa. Now that everything shifted, in an ideal world, I would have wanted to done the excursion myself with Debbie and gone to the forest. But there was some issue with that.
I would have two other questions, but maybe, I can ask one question and then we'll take the break, because the second question is also for Meredith and Marit, so maybe we'll have it at the end. So the question for me is, why are you looking for this female? I mean, why are you questioning this this issue of the end of a species? Why not just let it die, or find other issues to reproduce artificially by clones or genetic engineering? So why do you want to express on this side facing this lonely tree?
I think for me, it's just a beautiful story. And it's beautiful and a sad story of losing a species. I mean, all the males, there are males throughout botanical gardens, they're all clones. But the missing female, it evokes so many stories about us, for me, the biodiversity crisis we're facing, and what does it mean?
Okay. So thank you, Laura and Debbie. We'll have other questions, but we'll resume it later. Debbie, we put you on pause now, and we get you back after. I believe. Yeah, you will be. You can't read. Well, okay. Yeah, I wanted to ask you a large question about art-science collaboration, and a question that I did not ask you, Laura and Debbie, before, that how your collaboration started. And obviously it already changed the direction of a project. So I think it's very interesting because you started with an idea, you started the collaboration, it changed. Both of you had met before but never worked together. And obviously the project is developing while being built. I mean, it's, so I would like both of the two teams to say a few words about what it means, this art-science collaboration in those specific projects here. Maybe Laura, you start, and then we'll ask Debbie.
For me, for example, when we began the drone search, I had no idea the level of I had no idea the detail and how much more we could do with the technology for the project. So it's very interesting exchanging ideas and moving project in a direction that I had no, it just changed the direction of the project dramatically. I'll leave it. Maybe you want to go, Debbie?
Yeah, thank you. So Laura sent me an email saying that she had read an article I'd written on the Women and Drones website where I'd stated that potentially drones could be used in the search or monitoring, surveying rare species such as cycads. And she called my bluff and said, I've read this article, I'm working on this project, would I like to collaborate? So it was very fascinating for me. Definitely, I've never worked on an art-science collaboration. I'm very much a scientist. I'll be leaving all the artwork up to Laura. But it was very fascinating and a great opportunity to be able to try using the drone and the sensor in just ways we haven't used it before. So it was a very exciting collaboration for me, and as has been alluded to, the project is evolving as we go, and that's very exciting. And drone work really is like that because the use of drones in the conservation sectors is very new. So there is no recipe to follow. So you're kind of figuring things out as you go, which is a lovely space to be in, to be trying and experimenting. And you try something, it didn't work, you try it again. So definitely we're only at the beginning of this project, so we'll carry on. But thank goodness Laura reached out.
Meredith, do you want to add something to this collaboration, or do you think you have already answered?
Well, we can say how we met, I suppose, yeah? When was it, 2018? Yes, we met at an artist residency in Biella with several artists together. It was also like a kind of art science theme, in fact. And yeah, so we met there. We didn't do any work together, but we just spent like a week or two together. I forget how long it was, but
a week, yes,
a week together. So we know each other since then, and we kept talking about different things. And I don't remember precisely where the idea for this project came from. I think I was thinking about piles in this ecological sense, vaguely for some time. And then I guess I said something about it. I made a post on Instagram or something, and then you saw it, yeah?
Yes, this is how it was. I mean, there was also like this same thing about the holes and the piles, and just somewhere in the periphery I always think about it. Also, I mean, in context to stones and in mines and quarrying, and how when you take a big chunk of something somewhere and you move it somewhere else, how we don't really see it, but then it always creates creates disruptions and it changes something in the landscape very drastically. But also the small ones, like if you see a mole coming out, I mean, it's also there is a hole, but there's also a pile, and just these again very simple things. But they have always I never made a work about them, but they were there. And then I remember, yes, Meredith was sharing this really nice. There were like it was a sequence of images of there were like anthills and different kind of mounds. Of also very, I really liked also that it really looked different. There were like old photos and there was like maybe a drawing, and so it was these different techniques. And then it also hit me that but it's so interesting. I think it also actually a little bit came from this book, this idea of archaeology also, like what we do as humans, and what is this digging and what is this what is in the soil that is so valuable, but also we also put waste and like really things that don't even compose. So I mean, a bit these topics, but then it started. And Meredith actually also posted the open call. So, and then I really thought that you are connected to it somehow, and I was really, of course I want to work with you. But then, and this is how we happen to be here.
And I have maybe the last question. I don't know, maybe everybody is starving. And probably this question is targeting first to the scientist. This project, the overall project, is called, the subtitle is Biodiversity Crisis and Plant Resistance. And it turns out that the two scientists involved with the artist are conservation scientists, which I find it quite stunning, actually. And my question would be, is this conservation issue not more an anthropological and anthropocentric issue before being an ecological issue? What is your take on this desire of preserving and keeping alive, and specifically when it's targeted toward plants and nature? Well, I know. Now we have. Sure, you have 3 seconds each.
I just think we have a moral obligation to save things. I don't believe we have a right to make other species go extinct. So if I can contribute in a very small way to saving species, then that's something I'd really like to do.
Maren?
Yeah, well, I think I agree with that. And I guess also, but there are many reasons why people are actually motivated to save species, and the particular ways that they do so vary and have different end goals. So, in fact, I think people can be motivated for many different reasons, and there's not really one reason or one. It's not that there should be one reason. I think any reason is perfectly fine, and there are lots of them. So.
Laura, do you want to add something? To why should we preserve and conservation nature?
I think the wanting to save biodiversity is to keep ourselves alive, like without plants and not restoring the ecosystem or not preserving species, and we're putting ourselves at risk.
No, I just cannot stop thinking about piles. So I just think also that this is kind of a nice model also for this, like something that looks maybe boring or looks like it's not important or something that, in a way, it might be actually very essentially important also. I mean, exactly also from a human perspective as well. That, I mean, of course, it's important to take care. But I mean, I agree also with Meredith about this, that there are different reasons and motivations, and but that's all part of the pile.
Well, thank you to the 4 of you. Thank you to everyone that came tonight. I'm very grateful to see you. I'm going to switch to French for a sec. Donc, merci à tout le monde. C'est la dernière rencontre laser de la saison. Nous verrons ce que nous ferons à la rentrée. Déjà, je peux vous annoncer que le 23 et le 24 septembre, j'organise deux après-midi de rencontres et de conférences autour de l'art lié à l'espace extraterrestre, avec pour thème les imaginaires contemporains de l'espace, les imaginaires contemporains multiculturels de l'espace. Voilà, pour trouver le titre entier. Donc, si vous avez envie d'être tenu au courant et si vous n'êtes pas dans mes fichiers, ben, vous me laissez vos coordonnées. Et maintenant, ben, je vous rejoins tous autour d'un verre et de la suite du buffet. Merci beaucoup. Merci. Thank you, Marit, Meredith, Laura, and Debbie. Thank you for having been online that way. And everybody comes to Ars Electronica in September, where you will see the work by Laura. And we have probably a round table and more things. And anyway, Ars Electronica is always worth it. So please come and join us. Thank you.